In this mini lecture, I'm going to look at solving quadratic equations by using this thing called the quadratic formula. Now, remember, a quadratic equation, what's important is I need to have a squared term to have a quadratic equation. And so we have an equation that looks like this. Now, sometimes we can solve this by factoring. We can use completing the square. Completing the square only works really, really well if this a value is already a 1. If it's not a 1, completing the square gets a little messy, which we're going to see here below. That's how we come up with this quadratic formula. So I'm going to use this completing the square process to try to solve this equation right here. And so remember the steps. The first thing that I need here for completing the square to work, I need 1x squared. So I don't want that a. I want to get rid of the a. So how I'm going to do that, I'm going to take this equation and I'm going to divide both sides by a. Okay, so I'm going to get then ax squared over a plus bx over a plus c over a, and then 0 over anything else is still 0. And of course, y I divided by a, those a's cancel out, so I'm left with just x squared. This is really the same thing as just b over a times x. Let me talk about that a second here. This x is really x over 1, so it would be b times x in the top, a times 1 in the bottom. So although these look a little bit different, they really are the same thing. So we've accomplished the first step of completing the square, which is to make sure that my quadratic term, the x squared, just has a coefficient of 1. The other thing then I want is I want all my stuff with x on one side and then a constant on the other. This doesn't have an x, so this is a constant, so I need to move that to the other side. So I'm going to subtract c over a. Let me write that in red. So I'm going to subtract c over a from both sides of the equation. So that leaves me with x squared plus b over ax equals 0 minus c over a. That would be negative then, negative c over a. The next part, I have to find this sort of special number that I add to both sides. And to do that, I have to look at the linear term. That's where I have x to the first. I need to take half of its coefficient. Remember, when I say half of something, that of really means times. So I'm going to have to multiply this b over a times a half, 1/2 of the coefficient of x, and then I'm going to have to square that thing. Well, 1 times b is b, 2 times a is just 2a, and now if I square, I'm going to get b squared in the top, 2 squared is 4, a squared is a squared. That's this special number that I'm going to have to add to both sides of the equation. So it's going to look like this, and I know this is really messy. It looks a little intimidating. We had the negative c over a to start with. All right, so what happens next? In completing the square, if I've completed the square correctly, this left-hand side now should be able to be factored as a perfect square, as something times itself. I'm also going to have to start cleaning up this side, trying to add these fractions together. But to add these fractions together, I need a common denominator. So I need these denominators to look the same. So I'm going to have to accomplish a couple things here. So first of all, to factor this, let's see, I think I'm making those too big. Let me move over just a little here. I want to leave myself a little more room there. Okay, so x squared is definitely x times x. Now, this next part seems hard. How am I going to write this so that it's going to equal this when I multiply it out? It seems impossible. Well, it's not really, because it really should be the perfect square, so these two numbers should be the same. The things I stick in these last positions should be equal to each other. Think about, where did this come from? Well, this came from down over here. Where did that come from? It had b over 2a squared. So that's b over 2a times b over 2a. And that's just what I put here then. b over 2a, b over 2a. Notice if I do FOIL now, first times first is the x squared. Last times last, b times b is b squared. 2a times 2a is 4a squared. What about outer and inner? Well, I get b over 2ax plus b over 2ax. I get b over 2ax plus b over 2ax. Well, I would just add the coefficients together. B plus b is 2b. The 2a would stay the same. The 2's would cancel. I get b over ax, and that's exactly what I've got here. So this really does work to get me what I need. All right, so I've got negative c over a, but I need to turn this denominator into this denominator if I can. What am I missing? Well, I need a 4 and I need another a. So I'm going to have to multiply by 4 and a, but whatever I do to the bottom, I have to do to the top. So this is x plus b over 2a squared. Here I get negative 4ac over 4a squared plus b squared over 4a squared. I'm going to do just a little bit of rewriting here to get it into the form we usually use. I can put these into one fraction. It would be negative 4ac plus b squared. Now I'm going to take the square root of both sides of the equation. Remember, if you decide to take the square root in an equation, you also have to throw in plus or minus. So plus or minus this square root. I'm going to rewrite the numerator in the other order. Remember, I can take the square root of the top and the bottom separately. So I don't know what the top is, but the square root of 4 is 2. The square root of a squared is a. I'm going to move this term over to the other side by subtracting it. This is getting a little messy, so I'm not going to write it down. So I'm going to get negative b over 2a plus or minus this square root of b squared minus 4ac all over 2a. And when I put the numerators together, I get this result down here. This is called the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. To solve any quadratic equation, we just substitute the values a, b, and c into this formula and simplify. Note, usually these values are strictly numerical values and do not involve a variable like x. So when you plug in a, b, and c, you're never going to be plugging an x in or a y in on this right-hand side if you're just solving a basic quadratic equation. That's a mistake I sometimes see students make. They plug like a 2x in for b. No. It should just be 2. Okay. So we'll have some more examples of course, how to use this. Oh, one thing I just want to say. This is definitely a little complicated and intimidating. Okay, it looks a little intimidating. Don't worry, you're never going to have to do this again. The whole point is we do it once and for all that leads us to this equation or this formula, and now I just use this formula anytime I see an equation like this. I don't have to go through this completing the square process again. Although let me talk a little bit about that on the next page. So there are 4 common methods for solving quadratic equations. First, factoring. Now, for most people, this is the easiest method, leads to the fewest number of mistakes. The problem is it doesn't always work, right? There are equations that can't be factored easily. Second, the square root property. This really works well, does not usually lead to a lot of mistakes, but the equation must already be in a form where either we just have one term with the variable and that's squared, like x squared equals something, or the variable is in just one quantity in one set of parentheses and that quantity is squared. So if you see that situation, so I end up with something like just x squared equals some number, or I get x plus or minus some number squared equals some number. Or you can rearrange terms to get one of these. If that's the situation where you can see one of these kind of situations, then the square root property works well. Completing the square. Completing the square works really nicely if the squared term already has a coefficient of 1 and the linear term already has an even coefficient. So if I just have something like x squared plus an even number times x plus a number equals 0, in this case, completing the square works really well and doesn't lead to a lot of mistakes usually. Fewer mistakes than the quadratic formula for most people. Also, completing the square is used to do other things in mathematics other than simply solving quadratic equations. So you really need to make sure you're familiar with this technique of completing the square. Finally, the quadratic formula. This method always works. However, it's easy to make mistakes in 2 places. One, getting the signs confused, especially inside the square root, making sign errors. And secondly, simplifying the radical and the resulting fraction incorrectly. It can be complicated. It can be complicated to simplify, but there's mistakes, and I'll have some example problems where I'll talk about this a little bit. So in general, all 4 of these methods are equally good, but you should pick the method which seems easiest for you to use and with which you are less likely to make mistakes. However, you really should be able to use all 4 methods, especially if the instructions for a problem dictate that you use one of these methods in particular. And then you need to do what the instructions say.